back to differential calculus class. In this class, we're talking about total differentials of functions. Let's assume we have a function that involves one dependent variable z and two independent variables x and y. If you let x of its y to be equal to the partial derivative of z with respect to x, and we also let z sub its y to be equal to the partial derivative of z with respect to y. So total differential, which is the z is equals to the partial derivative of z with respect to x, then multiplied by the total change in x, which is dx, then plus the partial derivative of z with respect to y, then multiplied by the total change in y. So this represents total differentials of these functions. Now let's take a look at an example. Let's say we have this question, we have to find the total differential of this function. So let's say we're going to find the total differential. The total differential of, let's say we have z equals, let's say 3 x raised to the power 3 plus 5x y squared minus 6y raised to the power 4. And we have to find the total differential. So to find the total differential is very simple. We first need to derive the partial derivative of z with respect to x, then we multiply by dx, then we also find the partial derivative of z with respect to y, then we multiply by dy. So that we are going to do. So solution. So here is the function z equals to 3x raised to the power 3 plus 5x y squared when we have 6y raised to the power 4. So the partial derivative of z with respect to x will be equals to, that is, this function. So what we have, so we differentiate with respect to x, so we have 3 times 3, we have 9x squared. Okay, then we have plus, we differentiate with respect to x, so x will go, that will be 1, 5 times 1 times 5, y squared, we have 5y squared. This is partial derivative of z with respect to x. We also do the same thing for y. We have partial derivative of z with respect to y, which is equivalent to, then we are differentiating with respect to y now. How do we do that? We only differentiate y component while we hold other element constant. We differentiate this y square, we have 2. Now we bring down 2. So that 2 will also multiply this 5 here. So we have 10 x y, because we subtract 1 from that, then minus, we also differentiate this one, 4 times 6, that is 24, y raised to the power 3. Then our final answer, we now have the total derivative is equal to this. Don't forget, we write the first one, z sub x, which is 9x squared plus 5y squared. So put in bracket, then you have the x equivalent to this, then plus the other side here. So we have 10xy minus 24y raised to the power 3 minus 24y raised to the power 3. So we put in bracket, then we add dy, which is equivalent to this side. So this is our total differential of this function. Okay, so let me give you a question to also try. Let me give you a question to also try. So if you are asked to try this, you are expected to find the total differential of this function. Z equals to 2x raised to the power 4 minus 5x squared y raised to the power 3 plus 7y squared. So find the total differential of this function and drop your answer in the comment section. Thank you.